Today's video is on integration using residues. In today's video, we are going to find the residue of the function z into e power z by z minus 1 cube as its pole. See here, in the question, what is our f of z given? So f of z is given as z into e power z by z minus 1 whole cube. So in order to find the poles, what we have to do? We have to equate the denominator to 0. So what is the denominator here? That is z minus 1 whole cube. We have to equate it to 0, and it is very clear that z is equal to 1 is a pole of order. So it is a pole of order 3. So z is equal to 1 is a pole of order 3. And next we have to find out the residues. How to find out the residues? So here the pole is z0 is equal to 1 and order m is equal to 3. So now I am going to use a formula that is, so in order to find the residue, that is residue of f of z at z is equal to z0 is equal to, see here, limit z tends to z0 1 by m minus 1 factorial and d by dz power m minus 1 into this is z minus z0 power m into f of z. Clear? And now we have to substitute m value as 3 and z0 value as 1. See here in this, what happens here? So this will be limit z tends to, what is z0 here? Z0 is nothing but 1. 1 by, what is m here? M is the order value, that is 3 minus 1 factorial, and d by dz. So m value is 3, that is 3 minus 1 into this is z minus z0 is 1, that is z minus 1 whole cube into this is f of z. Clear? And see here, this will be limit z tends to 1 1 by 2 factorial into d by dz square into this one is z minus 1 whole cube into f of z. So what is this f of z? F of z is nothing but z into e power z by z minus 1 whole cube. See here. So f of z value is nothing but z into e power z by z minus 1 whole cube. So if I cancel this one and I have to make a derivative for twice, that is limit z tends to 1, 1 by 2 factorial. This is d square by dz square into z into e power z. Now I am going to use UV rule. So that is limit z tends to 1, 1 by 2 factorial. First time I am making derivative. So I am using this as u and this as v. See here, for z it is 1 the derivative, e power z I am leaving, and next time I am leaving z, and for e power z it is again e power z. And see here, and again I have to make a derivative, and again I am using UV rule for this. UV rule for this, and therefore limit z tends to 1. See here, limit z tends to 1, 1 by 2 factorial. If I make a derivative for one more time, for e power z it is e power z. For z this is 1 into e power z, and again z I am leaving, e power z is e power z. See, this will be limit z tends to 1, 1 by 2 factorial, and see there are 2 e power z's, 2 e power z plus z into e power z. Now I have to substitute the limit as z is equal to 1. So that is 1 by 2 times of 2 into e power 1 plus z as 1. So this will be e power 1. So this value is 3 into e power 1 by 2. Therefore our residue value, so the residue at z is equal to 1. See here, the residue of f of z. The residue of f of z at z is equal to 1 is 3 into 3e by 2. So this is the answer. And see here, let me explain you once again. Here the question is given as f of z is equal to z into e power z by z minus 1 whole cube. So here, in order to get a pole, we have to equate the denominator to 0. So z minus 1 whole cube is equal to 0. So clearly, z is equal to 1 is a pole of order 3. Therefore, we have to take the point z0 as 1 and the order value as m is equal to 3. So here is the formula. In order to find out the residue, that is residue of f of z at z is equal to z0 is equal to limit z tends to z0 1 by m minus 1 factorial into d by dz power m minus 1 into z minus z naught power m into f of z. Here we have to substitute the pole value as 1 and order value m as 3. So here pole value is equal to 1 and the order value m as 3, and we have to substitute in this. So after substituting, f of z value is this one, and after cancelling z minus 1 whole cube, we have to make double derivative for this, and after making a double derivative we have to substitute z as 1. Therefore, so this is our final value, that is 3e by 2. So this is how we have to solve. This is also so simple but most important question. Please practice and pass it on to your friends.